Hola, folks! This video is the last of Chapter 5. It's actually one of the last things that we're going to learn probably before Christmas break, so definitely something to celebrate. I think this is probably one of the easier sections of all of these trig functions, and it's finding the areas of triangles. Now, you're probably like, wait a minute, I know how to find the area of a triangle, and hopefully you all do. It's pretty simple, right? We know that the area of a triangle is simply just 1/2 base times height. But the problem is many of the triangles that we've been dealing with lately don't have a height. We don't know what the height of the triangle is. We just know the 3 side lengths or some of the angles. So essentially, if we look at this formula, we know what B is, right? B is the base, or in this case, it's this side of the bottom length of the triangle. So the issue is H. So my proposition is, well, what if we represented H in a different way, if we could rewrite it somehow? So for instance, let me ask you, what is the sine of angle A? Well, the sine of an angle is opposite over hypotenuse. So opposite of angle A is H over, and then the hypotenuse to that right triangle would be C, right? Because if this is the height, we know this is a right triangle here. So we've got H over C, and then if I want to solve to isolate H, I simply just need to multiply both sides by C, and then that brings us to H is equal to C times the sine of A. So now I have a different representation for the variable H. So let me use this expression and substitute it into the area formula. If I do that, then I get area is equal to 1/2 times the base times, instead of H, we're writing C times the sine of A. Now, the confusing part here is that we have 2 capital A's, right? Now, the sine of A, we know this is an angle. Here, we know that it stands for area, but so to not be confused, this particular areas of triangles uses the variable K to represent area, and that's just an understood thing. So we're going to change A to a capital K, and we're going to say that area is 1/2 BC times the sine of A. Now, of course, that's only with using angle A as a reference angle. Sorry, I'm making myself more room here. Using angle A as a reference angle, but we very well could have drawn the other 2 heights, right? We could have flipped the triangle over and had C as the base, and then had side A as the base as well. So this also means that we could have the formula, area formula, is equal to 1/2 times AB times the sine of angle C, and lastly, area is equal to 1/2 AC times the sine of B. So these are area formulas, and we're using K for area. So they look a little bit different than what we're used to, but what's great is that we don't need the height. We just need to know the angle. And notice you do have to memorize these, but notice there's a pattern to it, right? So you could easily derive this if you needed to. You've got BC and then the sine of the other angle. AB, the sine of the third angle C. AC, the sine of the third angle B. So you'll be able to catch on to those pretty easily. So let's put it to practice. Here's how it works. If I ask you to find the area of triangle ABC, again, let's round to the nearest 10th where necessary, to the nearest 10th. If I give you the following information, B is equal to 14, C is equal to 110 degrees, and capital B for the angle is 25 degrees. So let's look at what we have, and let's look at what we need. Essentially, when you look at these area formulas, what you're going to notice is, and this is a very informal way of saying this, so I like to put that in quotes. Basically, we need one of each variable, right? We need 2 sides, and we need the third angle that's different than the 2 sides that we have. So we just need one of each variable. Well, the information that we have in this problem poses an issue, because we have side B and we have angle B and we have angle C. So please know, going into this, there are numerous ways that you could approach this problem. So The way that I solve it here might be different than the way that your brain would attack it. But basically, I know I need to find something about A, whether that be a side A or an angle A, as well as another side length, because I only have one side here. So I'm gonna press forward. I know my my B's. So we're gonna use what we know about the law of sines to say B over the sine of B is going to equal C over the sine of C. So I'm going to use this to help me solve for the side length C. This implies, if I plug in what I know, 14 over the sine of 25 is equal to C, we don't know, times the sine of 110 degrees. So if I'm solving to isolate side C, I'm going to multiply both sides by the sine of 110. Let me do it on this side, the side of 110. Leaving us with C is equal to 14 times the sine of 110 over the sine of 25. And that rounded to the nearest tenth is going to give us a side length of approximately 31.1. So I'm going to like circle this for now and hold on to it for later. So look at what we've got. We've got side C, and I've got side B up here. So if I need one of each variable, let me go ahead and find angle A, and that's going to be pretty simple because I know the three angles of a triangle add up to 180. So then if I just take 180 minus, I'm already given these other two angles, right? So minus 110 minus 25, I get 45, which tells me angle A is going to be 45 degrees. So there is one of each variable, and of course one of them has to be an angle. So now using the area formula that has the sine of angle A, we're going to substitute in our information. So let me rewrite what that'll look like. We're going to be using K is equal to 1/2 BC times the sine of angle A. So that's going to be 1/2. We know that side B is 14. We know that C is that decimal that we found earlier, about 31.1, and again, that decimal continues on for a long time, times the sine of 45 degrees. So as mentioned in some of my other videos, the longer you keep values in your calculator, true values in your calculator, the more accurate your answer is going to be. So the issue is if you plug this expression into your calculator exactly as it is, you're actually going to get a different answer than what the textbook might say because you've already rounded once. So the idea is, if I were you in your calculator, hopefully you still have this crazy decimal value still in there because you just computed it. So I would just hit times, like if you keep on typing in your calculator and you just hit times, your calculator screen will actually say answer, which is going to know that it's talking about the 31.1, blah, 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 blah. And it's going to multiply that true value times, and then go with the rest of the problem. 1/2 of 14, or you could even put 7, times the sine of 45. So it's okay if you put these in a different order because with multiplication, it doesn't matter the order you plug it in. If we do that, you're going to get the answer that I'm looking for, which is an area of approximately 154.1. We're dealing with area, which is in square units. So make sure you put units squared at the end of your problem. Okay, so that is one formula to find the area of a triangle. Another formula, it's called Heron's formula, or you might see it as Heron's formula. I'm not sure the exact pronunciation of which one, and even Heron's has an N on it, but our book says it's a Heron's formula. And basically this one allows you to find the formula of a triangle. Sorry, let's do the area of a triangle, knowing nothing about the angles, but just knowing the three sides. Now, I'm not going to go over the proof, but I have links to 2 Khan Academy videos right below this on my webpage that shows you the proof of why this works. And if you have the time, it's actually really neat as to why it works, and just a ton of algebra to show that it cleans up this nicely. So the area using Hero's formula, we still use k, is represented as the square root of s times s minus a times s minus b times s minus c, where s is equal to 1/2 times a plus b plus c. And so again, this is knowing the three sides, a, b, and c. So this is Hero's formula. Pretty important. It deserves a bubble or a cloud or whatever that little squiggly thing is. And it's pretty simple, straight plug and chug. Again, I encourage you to go look at the video of the proof as to why it works, because it's pretty powerful. So for example, I want you to find the area of triangle ABC. Again, we'll do to the nearest tenth if A is equal to 14, B is equal to 9, and C is equal to 8. Well, there's really not any kind of extra work to do here. We're just simply going to plug this in. So I'm going to have, first we want to go ahead and figure out what S is, right? We need to define that. So if S is equal to 1/2 times A plus B plus C, that's going to be 1/2 times, my side lengths are 14 plus 9 plus 8, which is 1/2 of 14 plus 9 plus 8. It's going to be 23. So that's going to be 31, and 1/2 of 31 is 15.5. So S is equal to 15.5. So when we substitute that into the formula, area K is equal to the square root of 15.5 times S minus A. So that's going to be 15.5 minus A is 14 times 15.5 minus B, which is 9, times 15.5 minus C, which is 8. Okay, and then if we simplify these little by little, again, you could plug this in your calculator all at once if you want. I don't encourage you to do that because, you know, the more work that I see, the more partial credit that you can get should you make a mistake somewhere. So I'd like to see the simplifications if this were a free response question. 15.5 times 1.5 times 6.5 times 7.5. And when you multiply those, you're going to get the square root of approximately 1,133.4375. And then if I take the square root of that number, round it to the nearest tenth, I get the area K, which is approximately 33.7 units squared. And that is Hero's formula. So congratulations, you made it through the content for Chapter 5. Best of luck completing this assignment and your study guide for your test next week.